Here we have a factorial equation and we have to solve for the variable n. Okay, since we are solving for the variable n has to appear on only one side of the equation, either on the left side or on the right side. But here the variable n appears on both sides of the equation. So we have to get rid of the variable n on one of the sides. Okay, but we can get rid of the variable on the right side. For that, I have to divide both sides by n factorial. So I'm dividing both sides of the equation by n factorial. So this n factorial will cancel out. Okay, now what I'm going to do is on the left side, I'm going to expand this factorial n plus 2 factorial. Usually, if I have a factorial, I want to expand that one. What should I do? For example, if I have 7 factorial, so what I will do is I'll be writing the numbers in descending order from 7. That is 7 times, 6 times, 5 times, 4 times, 3 times, 2 times, up to 1 I have to write. In case when I expand the factorial, that is when I expand 7 factorial, for example, I just want to stop at somewhere in the middle. For example, I want to stop at the number 5. So whenever I expand a factorial and I want to stop at somewhere else in the middle, immediately I have to take factorial over there so that people can understand. So it does not stop over here. It continues up to 1. So both the results are same because here we have written the numbers from 7 to 1 in descending order. So here also we are writing numbers from 7 to 1 in descending order. So since we stop at middle, we take factorial for 5. So 5 factorial means it continues 5 times, 4 times, 3 times, 2 times, 1. So it's a very simple thing we have to understand. So in the expansion of a factorial, if you stop it anywhere in the middle, no problem, we can stop it, but we have to take factorial over there. Okay, here, if I want to expand the factorial of this number n positive 2 factorial, what should I do? So first I have to write n positive 2. So what should be the next number? Here when I expand the 7 factorial, first I write 7. The next number is 1 less than the first number. So here also the next number I'm going to write over here has to be 1 less than this number. So n positive 2 negative 1 means it's the simplification of this one is just n positive 1. And what is the next number? Again, you have to reduce 1 from this one. When I subtract 1 from this one, I'll be getting n. Still, I can write to get the next number, I have to subtract 1 from this number, then I'll be getting n negative 1. And if I subtract 1 from this one, I'll be getting n minus 2. It will keep going, and we have to continue up to 1. But I don't continue up to 1. I just stop at this number n. So since I stop in the middle, I have to take factorial over there. So n positive 2 factorial can be written as n positive 2 times n positive 1 times n factorial. So the same thing we can write over here for this n positive 2 factorial. So for n positive 2 factorial, we can write n positive 2 times n positive 1 times n factorial divided by n factorial. Okay, here you may have a question. So here when I expand the n positive 2 factorial, why should I stop specifically at n factorial? Because I have n factorial in denominator. So if I stop at n, I have to take factorial over there. So this n factorial can be cancelled. That's why I stop at n factorial. On the right side, we have 2550. So here we have n positive 2 times n positive 1 equals to 2550. Here we can multiply this 2 and we'll be getting a quadratic expression. So finally, by simplification, we can get a quadratic equation, but it will be time consuming to solve for n. Okay, here, what is the difference between the value n positive 2 and n positive 1? It's just 1. So this is a product of 2 consecutive numbers. So this is larger one, this is smaller one, because 2 is added to n over here, here 1 is added to n. So this is a product of 2 consecutive numbers. The larger one is n positive 2 and the smaller one is n positive 1. So we should try to write the number 2550 as a product of 2 consecutive numbers in the same pattern as we have on the left side. Okay, so how can we write 2550 as a product of 2 consecutive numbers? Okay, already I know that stuff, that is 50 times 50 equals to 2500 because 50 square is 2500. But here the number we have is little more than this one. So in these two numbers, I have to increase one of the numbers. I'm going to increase the first number by 1, that is 51 times 50. So what I get, so I'll be getting 2550. So 50 times 50, already I know that 2500 because I'm just getting a product closer to this one. So when I multiply to same numbers 50 and 50, I'm getting 2500. But if I want to get a result more than this one, I have to increase one of these two numbers. So just for trial and error, I increase the first number by 1. So when I do so, the product of 51 and 50, I'm getting exactly the number what I have over here. So 51 times 50 is a product of 2 consecutive numbers, and we have the larger one first and smaller one next. So we get n positive 2 times n positive 1 equals to 51 times 50. In whatever order we have the two numbers on the left side, that is first larger, the next smaller, the same order we have a product of two consecutive numbers on the right side. Okay, now let's take the smaller number on the left side. What is it? N positive 1. What is the smaller number on the right side? It's just 50. So whenever the products of two consecutive numbers are equal, so we can compare the smaller number on the left side and smaller number on the right side, or we can compare the larger number on the left side, larger number on the right side. But I compared the smaller number on the left side, smaller number on the right side, so they must be equal because the products are equal. Okay, to solve for n, I have to subtract 1 from both sides. The positive one, negative one will cancel out. I get n equals to 49. So I solved for n. So the value of n is 49.